of the world. This is again, I'm a singer, eternal voice. Welcome to the Science Academic Information Sharing of Information. Okay, this is all about related to physical chemistry, thermodynamics, and chemistry. This is all about enthalpy change of the formation of the reaction, problem solving. Let's start now. Have your pen and a blank sheet of paper, and let's do the practice solving of this particular topic regarding enthalpy change of the chemical reaction or enthalpy change of formation of the reaction. So all you have to do is to verify properly and examine closely the chemical reaction. Okay, something like this. There's a chemical reaction given, then you will be the one to make your chemical reaction, and then you balance the chemical reaction. Okay, like that. So I will read first, and then I will show you the problem. Okay, given the enthalpy change of the reaction below. Okay, aluminum solid plus hydrochloric gas is equal to aluminum chloride solid plus hydrogen gas. Calculate the enthalpy of formation of gaseous hydrochloric acid. Okay, the enthalpy of formation for aluminum chloride is negative 704 kilojoules per mole. The enthalpy change of the reaction is negative 856 kilojoules per mole. Then, in this manner, you have to investigate the words, the statements, how it is being presented in the question. Okay, you need to evaluate, okay, the phrasing of the words so that we can understand the breakdown of the sentence, so that we can understand really, what's really the formation, like that, the reaction, and then we can break down that, okay, component to component. Okay, I will give you 5 minutes to take a look with this problem. Oh my gosh. Okay, so I'll give you 2 to 4 minutes to write down in a blank sheet of paper, and then you can do also this in solving this one. This is the very not complicated and not complex really. Okay. Okay. In fact, it doesn't involve other quantities such as the Gibbs free energy, the internal energy, the density, the mass, the volume, the viscosity, the volumetric flow rate, okay, the mass flow rate. It doesn't require also overall material balance, energy material balance, like that. Okay, it doesn't involve also other equations of Stokes equation, Bernoulli's equation, okay, or any chuba-chuchu about ideal gas law equation. This is just very basic to consider, okay? Just develop the theory and the concept of the specific topic that we will be able to discuss to you right now in this specific problem solving, okay? Okay. Okay. Now I will get a blank sheet of paper, okay, to start now the computation, the calculation, or to give you the solution for this kind of problem. Wait a minute. Are we able to make my coffee first so that I can have energy to discuss to you guys very well? Okay. I need brain stimulant in my brain cells. Right? Talaga, and caffeine is responsible for that. Okay? Caffeine. This coffee has a content known as caffeine that's a very effective stimulator to give us energy in everything that we do. Okay? Something like, oh my gosh, I don't have water anymore. Wait for a while! Guys, I'll do the basic heat transfer process of heating the water into its boiling point so that I could be able to have a very hot water to drink for my coffee. There's a heat transfer from liquid to gas during evaporation process. Okay? Hello guys, are we using the microphone now? Oh my gosh. Talaga. Sorry.
The Bluetooth device is ready to pair.
Okay, again, I have to state the problem once more. Or once again. Okay. Okay, guys. Okay. Maklaro dili. Okay. Given the enthalpy change of the reaction below, aluminum solid plus hydrochloric acid that is in gas state. Aluminum chloride solid plus H2 gas. Calculate the enthalpy of formation of gaseous hydrochloric acid. Okay, the enthalpy of formation for aluminum chloride is negative 704 kilojoules per mole. The enthalpy change of the reaction is negative 856 kilojoules per mole. Okay. As you can notice, guys, the enthalpy of formation of the reactants and the products usually expressed in negative units. So you can have now an idea, oh my gosh, at standard temperature and pressure at 1 atmosphere and 25 degrees Celsius at room temperature or standard temperature pala siya talaga. So usual products and reactants behave spontaneously all throughout the process in its natural way. Okay, you don't have to heat it. You don't have to add internal energy, or you don't have to do something in order for that to become spontaneous. Okay, because of the value of negative. So you always see that in the table. Negative talaga siya in most cases. Okay, so meaning to say, most of the chemicals, organic and inorganic, in its standard temperature, 25 degrees Celsius, the enthalpy change of the formation of the reactants of the products are always negative or spontaneous. Okay, something like that. That's your first idea already. So supposedly, not supposedly, so it is very sure that also your enthalpy formation of the reaction should always be negative. Okay, because in the given here, there's no positive. So it is understood to have a negative value also with your answer. So that's the second, identification. Okay, like that. Okay, later on, I will just get the water, hot water. Oh my gosh. Talaga. Wait for a while. What's happening? Oh my gosh. Hello guys, this is thermal equilibrium. Talaga, in thermal equilibrium. And this is zero law of thermodynamics. Okay, remember that one, thermal equilibrium? Okay, but never mind, I off the AC. There's no temperature, there's no cold temperature anymore. Okay, so the transfer of heat is not very spontaneous. Talaga. Okay, so during mixing, there will be a heat transfer through conduction. Okay, the molecular concentration of the coffee will be dispersed in a liquid surface. Okay, and then it will be having a strong kinetic energy and a strong intermolecular forces. The molecules will collide with each other. Okay, and then budding, the molecules will escape to the atmosphere. And I thank you. Ganon. You heard my voice? I'm talking about thermal equilibrium during preparation of the coffee. Strong coffee without sugar additive. Wow. Talaga, without any sucrose. Oh my gosh. And this is also very effective in lowering my blood pressure. I have a very normal blood pressure. Okay. Oh my gosh. And lower also the risk of type 2 diabetes. Okay, drinking coffee without sugar. My gosh. And I'm very slim as of this moment. Charot! My gosh. Okay, let's go back to business. Business as usual. Okay, now, what is being asked to the problem is really the enthalpy of formation of the gaseous hydrochloric acid. You have that the chemical reaction is given. Okay, and all you have to do is to balance the chemical reaction. Okay? Really different from the other example because that was not given the chemical reaction. So, like that. Oh my gosh. Something like that, okay? Okay, so sometimes guys, if the problem is like this and there's a lot of given, and then For example, the area of the pipeline, ganun siya. Okay? 1 mole of ganon, hydrochloric acid in gaseous state will go to the pipeline with diameter like that, and then the velocity. So even though the problem is just like an enthalpy situation, then you have to apply the Bernoulli theorem of momentum transfer, okay, in which equal to the let's say volumetric flow rate 1 is equals to volumetric flow rate 2, mass flow rate 1 is equals to mass flow rate 2. Okay, what's volumetric flow rate? It's gonna be the area times density times the velocity. Okay, something like that, blah blah blah, so and so, and you have to cancel that one. But in here, it's very simple. There's no other quantities. Okay, and momentum transfer. Okay, or in the transport phenomena, something like that. Okay, gimingo mo po transport phenomena, which is the mass transfer. Okay, momentum transfer. But this is heat transfer really, because this is enthalpy. Okay, at least pasok yung isa, which is the heat transfer. Okay, so I love. This is my, this is my 40. Charot! Like that. My gosh. Wow, grabe. Sarap. Oh my gosh. Oh, the transfer of heat energy from the mixture of coffee and water going to my system, internal system, going to my digestive system, in the esophagus, like that. Charot. In the abdominal area. Oh my gosh. Going to the other parts of the organs inside my body. Ganon. Okay? And there's a physiological chemical reaction inside. Okay? The transfer of heat energy, sure. And I cannot determine how many calories, because I don't have the measuring device to measure the heat, which is the calorimeter. And the process is known as calorimetry process. Okay? Something like that. You remember that one in physical chemistry, right? So calorimeter. Calorimeter is an example of first law of thermodynamics. Okay? And heat engine is an example of second law of thermodynamics. Okay, so you should also familiarize what are the examples so that you can use easily the applicability of the formula. Okay, not only reading like that. At least when you see directly, a heat engine like that, bingo. Use immediately the first law of thermodynamics, something like that. Use that formula. It's gonna be like that also sometimes to make it quicker. Okay, like that. You have the concept and furious. Okay, but advantage lang yun talaga ang mga very good in problem solving, right? Never mind. Okay. Okay, let's go na ha. So, aluminum solid. Okay. Aluminum solid plus HCl gas is equals to aluminum chloride. Okay. Solid plus H2 gas. In the laboratory, the gas state will just evaporate to the atmosphere. So what will be found in our visualization, in our naked eye, is really the solid one, the aluminum and aluminum chloride. Usually it's white, aluminum chloride, a little bit of, pale white, something like that. The color. Okay, and this HCl will just escape to the atmosphere because it's gas, common sense. So what will be left is the aluminum solid and the aluminum chloride in the flask, or it could be in the, graduated cylinder or whatever, any types of container inside the laboratory. Because you are just purely mixing here without adding heat. Okay? Because this is spontaneous, right? As I tell you over and over again. Okay, so we need to balance the chemical reaction or chemical equation. Okay, my gosh. But first, you have to take note if the problem is giving the correct chemical reaction. Sometimes also, they give the wrong chemical reaction, and then you have to do it in your own to make it very correct or a perfect chemical reaction sometimes, but not all the time like that. It really tests your, mental ability sometimes. Okay, but it doesn't express always most of the times like that. But there are also questions that they will give the wrong chemical reaction. You will be the one to make it perfect. Okay, aside from giving the products, like aside from balancing the number of atoms, so you'll be the one to do all. Okay, but in rare cases only, because most of the times it will be given and presented in the question. Okay, but sometimes it will be like that only. Okay, because kini magong mga subscript is very difficult to put also when you encode that in your computer, right? Subscript or script. It's very tasky also sometimes to put, right? When you encode, you have to go to the, to the format. Okay, and then you have to click the superscript, you have to click the subscript. So to avoid that one, the questionnaire will state only the word and the statement. For example, aluminum chloride, it's written in words, not in formula. Because aluminum chloride has subscript 3, and sometimes they are very lazy to put 3 during the encoding process of the question. You understand now the point sometimes like that. And so many subscript, so many superscript, something, especially the exponent, superscript in mathematics. Okay, and it's also very boring to put that all the time. That's why they make it in words. The question will be stated entirely with words and statements. And then, for example, if you are not you don't have a strong foundation of, the formulation of the chemicals and any chemical, and then you don't have an idea for that much, then it will become a problem also for you in your part or in my part if I don't memorize the mechanics of those different elements and compounds when reacted together, something like that, and what's the product. Then you have also to understand and familiarize what are those usual products will be produced in the types of reaction. For example, combination reaction, synthesis reaction, decomposition reaction, combustion reaction, single replacement, double displacement, and double replacement, single replacement and single displacement, something like that. You have to know that all types of chemical reactions, so that you will be able to master na if the problems will state like that in the questions during examination. Okay, due to the fact that you will not give all the time the chemical reaction, you will be the one to do all. Okay, so you are on the maximize your your what do you call the one, your not mathematical, your analysis potential. Wow, may ganun. The way how you interpret and understand the problem, that's analysis potential. Okay, so you have to maximize. Okay, maximize means you have to do a lot of effort. Okay, and dig it out. Okay, if you cannot just dig it out, research, read, like that's what I mean of maximize your potential or maximize your analysis potential. It's not enough that you will never dig it out. You will really dig it out so that you can really understand what's going on. Okay, something like that. Just like reading a news in the social media, then you don't have to believe immediately. You have to verify and validate the source. Okay? For example, there are 3 or 4 sources, then investigate which among them produce the valid statements for that particular issue in social media. Me, I don't believe immediately. Okay? I have to verify the sources. Even though they are professionals or doctors or whatever, I have still to verify other sources. Okay? That's why I don't fun and loving reading, video sharing in my Facebook. Sometimes I don't entertain that one. Okay? I don't even watch sometimes. Especially negative video sharing in Facebook. I don't really read that one because it will mislead me sometimes. Okay? So I am very, very frank to that. They'll send in the messenger, they have sent video sharing about the negative for that, blah, blah, blah. And I will never open that because if I open that for 2 minutes and 3 minutes, I feel something medyo the atmosphere of presenting the video looks like it doesn't inspire other people's lives. It looks like it discourages the humanity, something like it looks like it doesn't give us the motivation, okay, to be strong, it's really negative. So what's the purpose of doing that to me? Okay, so it will just discourage me somewhere along the way. So better not to see that. Okay, that's my point really. So I'm very very frank. I delete it immediately. Okay, especially sending vaccination topic like that and worst content. I don't even read. Delete it immediately. Okay. Like that because the world of today is very corrupted now. Okay, there's a lot of fabrication of statements. They have to modify for their own interests so that a lot of people will watch their videos in social media. Okay, they have to earn more revenues, so they make their videos more attractive and presenting that in a reverse manner so that somebody will click because it is more interesting to their eyes or to their minds, right? So that's the usual in social media. They have their own YT channel also. They have their own Facebook channel or pages. So in order to be others will pay attention, then they will create a video that is more sometimes surprising, that is look like unusual and very rare, that does not happen in normal situation. Okay, something that's of course they will click that one and they're fun of reading that one. Oh, like oh my gosh, and then it creates phobia, okay, fear, fear, and it creates depression, stress by yourself. Okay, so why entertain those kind of videos? Okay, that's not positive in the first place. It will never motivate positivism. Okay, especially the world of science is not like that. Okay, the world of science is through experimentation. You need to re-verify again, verify, do it again, so that your experiment will be successful and valid and reliable to the public through data in science experimentation after your scientific research has been done. Okay, there's no quick scientific research. Okay, it's done for how many years. Okay, but it will just be demolished. It will be just destroyed by others who created a post against to those science research. It looks like they are something hopeless. Okay, maybe those other professionals don't have a very good job like that and they are just in their homes, but they are professionals. Then they will create also a videos that that will in contrary to those who are in the agency, okay, in the private sectors, in the public sectors, so that so many people will watch the videos, something like that. Okay, because they were not also given a chance, for example, to work in the World Health Organization, and there are only few competent persons selected there, and they are envy or jealous, even though they are also doctors, things like that. Okay, world of competition. Okay, because not all of us will be given a chance, okay, to have a very good package in our career. Some are low income, some higher income, and very income. And it doesn't mean also that if you are very intelligent, you have a good income. It doesn't mean like that. Sometimes it needs to abide with the faith, FATE, the faith given by God to us. Okay, even though how much we struggle, okay, to work hard, and then sometimes we cannot get that what's on our mind, what we are looking for, what we aim for. Okay, so it's gonna be like that. Maybe those kind of professionals are doing that in contrary or against to those who are in the nakapwesto in those government like that, in international organization, because not all will be given equal opportunity. Some are not, some are given. So that's why they keep on opposing, okay, the research of those who are in the government or in the in the WHO, in the CDC. Of course, because it's money, okay, it's business. Okay, then for example, if those individual professionals have allies and partnership to destroy the image, for example, to destroy the image of Pfizer, to destroy the image of AstraZeneca, okay, so there's another vaccine that will appear, okay, and they give money for this person and he's a very intelligent doctor or intelligent scientist. Of course, they will try to, to destroy the image of this popular, business. Okay, so that nobody will buy any more of their products. It's just like that. The story will be like that. Okay, so it's a competition. They will use everything just because of competition, even though it's already negative and not good for the humanity. Okay, you get the point? Something like that. Okay, so very loaded with negativities, something like that. If we introduce this kind of topics for science, and they will really automatically they will oppose. How about do a research first before you oppose and present your facts and data? Then let's do the answering both parties in what area that I am wrong, you are wrong, so that we will agree in some philosophical statements that we are not agreeing for. How about like that? Okay, rather than entirely putting negative statements to the good research for this individual, something like that. Okay, it's not good really. That's why I keep on deleting video sharing that's very negative. Okay, especially for any scientific research, especially vaccination or whatever, chuba chuchu, medicines like that. Oh my gosh! And then if they will present their video at first, oh my gosh, very really distracting in your eyes. Okay, oh my gosh, it looks like impossible. Okay, and then somebody died immediately. Oh my gosh, what's this? So it looks like very animated, fabricated, scripted, something like that, and it doesn't relate to the actual scenario, what's going on. Maybe they cut something, they edited something like that, just to put contrary or against to those who are making positive statements to those medicines, vaccines, or whatever like that. Okay? It's gonna be like that. So don't believe immediately. Verify the sources of that particular post that you read in Facebook. Okay? Do not be one-dimensional. Okay? Gather all the sources. Okay? Practice that in your way of reading. Do not believe immediately something. Me, I will research by myself. Okay? Even though it's listed already in the books, it's presented like this, I still have to research maybe it's really correct. Like that. Because one time I read also in the website in the Wikipedia, they're giving also a wrong chemical reaction. Okay, really? And then, oh my gosh, why like this? And then I'll try to go to other sources. Okay, and I don't have the chance to correct that because that is Wikipedia already. I'll just leave it there. Okay? Maybe the one who make that one is not a chemical engineer. That's why his reaction is wrong. Something like that. Or maybe clerical error, they don't review it. There's no proofreading after the article. So that's why they released it immediately to the public, something like that, okay? So it should be reviewed properly before circulating that in the public or in the world of social media. Okay, that's the steps in journalism. Before presenting the articles, review it. Okay, have a proofread for lines to lines, phrase to phrase, including the spelling and the grammar of the paragraph to paragraph, especially in building your title also, something like that. And then you have to state your sources also somewhere along the way, because the readers nowadays are very clever to identify, oh my gosh, this is really not coincide to this, blah blah blah. Okay, then we will comment there. Okay, something like that, and then there will be a conflict of statements in the comment section, and you will never be agreeing with each other. So you'll be quarreling in the comment section in the YouTube, the Facebook, so it will never end. Okay, so that's why you need to have your own research to validate the sources of the posts and videos that you see in the social media. Okay, something like, do not believe immediately. Okay? Do not be one dimensional. You should be multi-dimensional, person. Okay, meaning to say, do not rely on one source. Okay, verify. Something like that, especially in scientific research or sciences, because this needs really factual statements, proven and tested, really through experimentation. Okay, but for chika chismes like that should be so well. Maybe it will be fun of reading that one, but still you have to verify that one. Maybe criticizing already the reputation of the celebrities, of the artists, even though that is not true. right? So you have to evaluate it all. Oh my gosh, my coffee is getting colder now. There's a heat transfer from high temperature to lower temperature. From hot environment to cold environment, there's a heat transfer of energy molecules. Wow, ano ba yun? Heat energy talaga. Okay, go. Oh my gosh. Oh, i-time check na, Mikey. Oh my gosh! We're sorry. The spoon was dropped. Wow. Dropped. We did talaga. Past tense. Charot. Grabe. Okay. Oh my gosh. I still have to do my routine exercise after this. I have still more. Okay. So my time is very budgeted. Okay, really. My life cycle is very budgeted. Oh my gosh. Wait. Pasingal-sangal ako pero ginhawa ako glaw. Charot! Okay. Balance the chemical reaction. Okay. Aluminum. Aluminum in the right and aluminum in the left is balanced. Yes, at first look it is balanced. And then we need to consider the chlorine first. Okay, so chlorine in the left and chlorine in the right is balanced or not? It's not balanced. Oh, okay. I have chlorine in the left, which is only 1. And I have chlorine in the right, which is 3. Okay, so the deficient number of atoms belongs to the reactant. So I must let the value of X equal to the number of atoms that shall be inputted beside the HCl algebra. So we'll put X. This will become an X HCl. Okay, now solve in algebraic expression. Okay, so since there's no subscript in HCl, so we will just say that 1 times X. So this is X equal to the 3 atoms of chlorine in the aluminum chloride in the product, because I put equal because this is an equilibrium stage, so equals to 3. Or else, if there's no equilibrium state, I cannot balance the chemical equation. Okay, that's the concept there. Okay, you have to put X is equals to 3 besides HCl. Okay, like that. Okay, you should master that one, because this is really the foundation of physical and chemical principles coverage in chemical engineering board examination. Okay, like that. Okay, now we go to the aluminum finished, chlorine finished, and we go to the hydrogen. Okay, hydrogen gas. Okay. The gas should be balanced last. The elements or the solid should be balanced first. That is a procedure. Okay, so hydrogen gas. Okay, in the left side, we have 1 mole of hydrogen. Okay, still 1, the same as chlorine, right? Now, in aluminum chloride and H2 gas in the product, okay, that is 2. Why 2, sir? Because subscript 2 times 1 mole sa kilid sa H2 or beside H2. So, I will now let the value of X as the number of atom beside hydrogen gas in the product side. So, I will put X. So, X mole times H2. And now, equilibrium state. I could say now, 1 is equal to 2 times X, because subscript times the number of mole of the H2 side. This is gonna be the proper discussion of balancing chemical equation. Okay? Like, it's not only trial and error method, because the students will not understand that. Okay? Because a lot of numbers will be trial, error, so the students will be wrong. Okay? It should be like this in interpreting in algebraic expression. In a mathematical expression, something like that. 2 times X equals to 2X. Solve for the value of X. Ganon. Okay, so 1 is equals to 2X, therefore very easy. X is equals to 2. Since we get the value of X is the number of mole of H2, put that beside H2. So 2H2. Okay, now we done to the 3 elements, the chlorine, the hydrogen, and the aluminum. And I will write the chemical reaction. Okay, so aluminum solid. So you will do this in the entire chemical reaction, whatever chuba-chuchu. There's a lot of chemical reactions all over the world or the universe. Then do this process over and over again. Okay, like that. Okay, so plus, I will now put 3 moles of HCl because that's the value of X beside HCl. So 3 moles of hydrochloric in a gaseous state. Okay, like that. 3 HCl plus gas. Okay, is equal to aluminum chloride 3. Just copy, okay, because we did not involve that in our balancing before in letting X, right? So aluminum chloride solid. Okay, now hydrogen gas will be equal now to 2 moles of hydrogen gas is the value of X. Okay, so 2 moles of H2 gas. Okay, now balance the number of atoms in reactant and in the product so that it will be equal. That meets the law of conservation of mass under law of conservation of matter. That's why we do the balance of equation, because the purpose and the objective of that is through the law of conservation of matter and the law of conservation of, there's a purpose. Okay, that's why we do it. It's not enough to say we need to balance this. There's a purpose for that, to meet that theory and concept regarding law of conservation of mass and energy matter, that is the number of atoms of the reactant is equal to the number of atoms of the product, the total, okay, in each side. So let's check. Aluminum, how many atoms in the left? I don't have to write this, I just have to state it. 1. In the right also 1. Perfect balance. Ganon. So chlorine, 3 moles of chlorine in the left and 3, okay, also in the right. Atoms, 3 times 1, 3. In here, in the reactant, the atoms is 3 also because there's no subscript of chlorine. Ato ni siyang klaroon. The subscript, mauna ang number nga gibutang sa ubos. Okay? Ang superscript mo na ang number nga gibutang sa taas, or that means exponent or raised to the power something. Okay? So that's the difference between superscript and subscript. Coefficient mo na ang gibutang sa kilid sa element and the compounds. If I will speak Sotero, what is the number of atom of HCl? So that means coefficient times the subscript. Okay. So the coefficient is technically equal to the number of moles only. But the atoms is coefficient times the subscript. Okay, just put that in your brain cells, okay, especially first year chemical engineering, okay, BS chemistry students or any physics or sciences courses in university or institution. So we start with a basic talaga siya. Even in high school, it's already taught, right? We'll just keep on repeating this, okay, like that. My gosh, my coffee is becoming cold. Heat transfer. Wow. Okay. So, hydrogen balance, take a look. Hala. So, Sotero, it's not balanced because we have hydrogen, 4 atoms in the right and 3 atoms only. And what should I do now? Again, second attempt. So, let X as the value of H in the reactant na siya, because in the reactant is the lesser manggod siya. So, it becomes now 3x. Okay, 3 times x. You should not eliminate the number you already put there in your first balancing moment. Wow, moment. You should not eliminate. So, this should automatically 3 times x. The new x that you let the number of hydrogen to balance. Because the hydrogen atom or molecule is being connected to the HCl. It doesn't break up. Okay, so that's the purpose there. You don't have also to break the 3 and the x. So it's become 3x. Okay, so 3x or 3 times x is equals to 4 atoms of hydrogen. Again, algebra, fraction. Solve for the value of x. X is equals to 4 over 3. Wow, bongga. Improper fraction. My gosh. Now, we have an improper fraction here. Do we have to eliminate the improper fraction here or as is? Now, take a look with your problem here. It states, okay, calculate the enthalpy of formation of gaseous hydrochloric acid. It doesn't state 1 mole of gaseous hydrochloric acid. English is very important in interpreting, ha? So, calculate the enthalpy of formation of gaseous hydrochloric acid. It doesn't state 1 mole of gaseous hydrochloric acid. So, this time, we need to eliminate the fractional form of the number of moles. In reverse to the first problem I presented, that it stated in the problem 1 mole of ethanol. Okay? It depends on the problem. Okay, but without any problems presented, you go back to the natural situation that you need to cancel the fraction because fractional atoms is behaving abnormal in a natural process. There's no fractional atoms. The purpose of this fractional atoms here is just only for the purpose of computation and calculation, but it doesn't occur naturally in the environment or in the surrounding. Just the purpose of understanding how to calculate enthalpy, just like that. Only theoretical aspects, ganon. But in the real sense of the world, there's no fractional number of atoms existing in the universe or in the atmosphere. It should be whole number. Okay? Example. Water, like that, okay? H2 plus oxygen gas equals to the water. I have to balance that equation, right? And there's no such 1/2 oxygen gas is not like that. It should be 2 or 1, so like that. But for the purpose of calculation, theory like this, then you can have the fractional. It depends on the problem. But what I mean in natural process, in existence, in the world, or in the planet Earth, or in the environment, or in the surrounding, okay? Or what do you call that? Okay, so third attempt, we have to put the fractional form, right? Okay. Let's put now. I have to get another blank sheet of paper. Oh my gosh! What's happening now? Oh my gosh! I'm checking with how did I last time? 96.3 W rock! Okay. It's very enjoyable class if you really understand what you are doing, right? That's the clue of happiness in this world. If you really understand what you are doing, then you are happy and enjoying that. Okay? But then if you do something that you did not understand, so you will not be happy. Okay? Something that's the clue of happiness in the world. Charot. Okay? And of course, in our day-to-day life, we need also to balance the equation. Meaning we balance our personality or behavior, mentally, physically, morally, spiritually, psychology, like that. So we need to be balanced also as a human being. Okay, something like that. It's just the same also the way we balance the chemical reaction. The analogy is just the same. If we have a balanced chemical reaction, then we have also a balanced human being exists in the planet Earth. Ganon. Okay, go back to the chemical reaction. So, aluminum solid, okay, pasensya na, very talkative. Aluminum solid plus 3. So, if that is 4/3, guys, then we need to put the 4/3 already, in the, here, in the left side na talaga siya. So, this is gonna be like this, 3 times 4/3. Oh my gosh, 4/3 talaga. Ikulbaan ko. Charot! 4/3 HCl gas is equals to aluminum chloride gas plus 2H2. Okay, ganun siya. Take note. Let's do the algebra once again. Okay, so this becomes simplified. And every chemical reaction, just like mathematics in the topic of polynomial, if you can remember that one, We have the quadratic equation, binomial, polynomial, trinomial. We need to simplify really so that we can obtain the correct form of that kind of polynomial, something like that. Just like chemical reactions also. So aluminum solid plus 3 times 4, 12. 12 divided by 3 is 4. Wow, perfect. So 12 divided by 3 divided by 4 cancels 3, so 4 HCl. Okay, 4 HCl cos. Let's balance again. Maybe I'm wrong, huh? Okay, it's very enjoyable. Okay, so it's very enjoyable, really, guys, to solve really on the spot, not scripted. Okay, really. And then somewhere along the way, you will become wrong, and then you can correct it. It's enjoyable, right? Rather than presenting that to the audience perfectly. So it's very scripted. There's no challenge. Okay, aluminum chloride 3. That's only my own opinion. Okay, that's subjective, huh? Okay, subjective, meaning it depends on the person's thinking and perception. Huh? For me, that's not really challenging if you do the vlogging in a scripted manner, because most of your solving problems will be perfect. Okay, there's no error, and human being is not perfect. Okay, subject for errors. So how come? So meaning to say, you know what I mean. Okay. Okay. So this I love on the spot solving problems. Okay. So this one, I need to have the final balancing equation the 3 times attempt. Okay. Now aluminum left 1, right 1. Ganun siya. Okay. And then chlorine. Okay. Chlorine. What's happening for the chlorine now? Okay. So the chlorine is not balanced. Okay, then what happened to your hydrogen? Hydrogen is already 4. And then you have to have your 4 attempt. Ganon! Ang saya special. Okay? 4 attempt talaga. Okay? So, okay, 4 attempt naman ka. So, again, unahon na gini mo ang chlorine. Okay? So, chlorine is 4 on the left side. Okay? Like that. Okay. And then chlorine is 3 on the right side. So which is deficient in the product side, right? So you let X as the value of chlorine. Okay, so this is X. So this is 3X. Ganon. So 4 is equals to 3X. And X is equals to 4 over 3. Again, a fraction for the third attempt. Okay? Then, put that 4 third in the X. Ganun lang siya. Okay. Okay? Kaya na-balance na ang hydrogen, don't touch it. And then the aluminum, balance, so don't touch it. Something like that. Okay? So we are now in the chlorine. So again, simplify. It's gonna be like this, guys, huh? And then if you found errors, again, go back. Okay? And I'm teaching you the systematize of doing. Okay, like that. Okay, let me solid plus. Actually, if you're good in IQ, you can troubleshoot anyway. Trial and error method. Okay, like that. Very quick. You don't have to reach this part. Because you can put like this, try 2, try 3, try 4, try 4. But again, you don't use the correct theory for that. Okay? So 4 HCl. To do super intelligent talaga. Yung mga you know what I mean. Okay, 4 HCl. Mga genius. Okay. So this is gonna be 4 third over like this. Okay. Okay, plus 2H2. Okay, ganon. Guys, muna na siya. Okay, very clear ha? Muna na siya. Natay fraction. So what we'll do to the fraction now? We will multiply both sides. And then, Sir Sotero, why did not multiply the both sides there at first? Because that is only for the reactant, not for everybody. Not for the reactant, not for the product, only for the reactant. That's why we need to multiply that there. Here, it's both naman talaga siya to cancel the fraction. Okay? So, this is, okay, like this. Okay, this is multiply by 3 ha, to, to cancel chuba chuchu. So 3 aluminum solid plus 12 siya. Uy, kulba kayo. 12 moles of HCl. Ay! Kada ko. Nakakaloka dyan. So 4 moles of aluminum chloride. Lawin, fairness. 6 moles of H2 gas. Now balance for the 4th time. That's why some students will say very difficult the balancing equation, because the technique there is you have to be patient. You have to go with the process. Okay? And then they want really to make it fast to obtain the balance chemical reaction right away. Then that's why, very difficult balancing equation topic. It's not difficult. All you have to do is to be patient. Okay? Ganon. So balance again for the 4th time. Or for the 4th time. Okay? Aluminum. Oh my gosh. Okay. Aluminum now will be 4 plus 1. Okay? So 3. Okay? Aluminum in the right. 4. Ganon siya. And aluminum in the left is 3, not balanced again. Imagine not balanced again. Now we need to do another 5th attempt later. Okay? We have the H. Hydrogen is 12, balance. Hydrogen is 12, balance siya. Okay? The chlorine is already balanced, 12. And the chlorine is already balanced, 12. So what we're gonna do here is to add more chlorine in the aluminum in the right side to make it balance. Actually, you need to add 1 lang siya, pero we need to do the equilibrium process. Okay? So 3x. Okay, 3x is equals to 4. X is equals to 4/3. Okay, and now we have another equation. 4/3 aluminum. Okay, grabe. This is 5th time ha. Char. Nakakaloka. 12 HCl gas is equals to 4. Okay, aluminum chloride, okay, plus 6H2. Okay, ganun siya. Okay, now, okay, you need to balance. So, again, there's a fraction. We need to times that with 3 to cancel the fraction. Okay, so we have 4 aluminum, okay, plus 12 times 3 is 36 moles of HCl. Don't be afraid, because we need to use the least common denominator also in rule in algebra ha, to make it simplify. Later na lang siya. Okay? So 12 aluminum chloride. You remember the rule for LCD? Less common denominator, less common factor, right? And that's discussed in our elementary level of mathematics. We will apply that here also. Okay? Plus 3 times 6 is 18H2. Labongga. Nakaloka. Okay. Let's investigate. Okay, for this. Okay, investigate na kita per me. Okay, so aluminum. Okay, solid. This is for the 5th time. Okay? Oh my gosh. Solid, 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 solid. Okay. Now, your hydrogen is balanced. Check. Yes, 36. Your chlorine is 36, the same. So what about your aluminum? Aluminum 12, it's not balanced. Okay. In this case, you need to set maximum of attempts in your chemical reaction balance of the equation. Okay? Like actually, we can do the direct, but we're just showing you the, the step by step. Okay? In this case, class, if you have 5 or let's say 4 lang siya, 4 to 5 attempts, not yet balanced again, you have to review your chemical equation. Maybe the type of chemical reaction you validated is wrong. That's why I told you, right? Some problem solving give the incorrect chemical reaction. You have to prove that it is correct. Because sometimes they put not correct chemical reaction. You are the one to make it correct. That's the logic there, okay? So we need to go back for the chemical reaction here in the problem. Okay. So aluminum solid plus HCl gas equals aluminum chloride plus H2. So first you have to review the type of chemical reaction. What type of chemical reaction is this? This is single replacement chemical reaction in which the atom of hydrogen will be displaced by the atom of aluminum. It's correct. And then the H of the HCl will go to the product and will exist as a gas. H2 gas is correct. Okay. Now investigate the number of charges. Okay. Okay, HCl correct, aluminum correct. Okay, it's gonna be correct like that. But take note, it's really correct not to put the subscript free. Yes, because it's in the free state. Don't put subscript for that. It's okay. It's aluminum only. Okay? And then aluminum chloride, so it will be, what do you call this one in chemistry? Displacing the number of atoms, changing the number of atoms from aluminum will transfer there, and chlorine will transfer there. It's okay because chlorine is negative, and like this. So that's a redox equation, reduction in, okay, and oxidation reaction. It's correct. Okay, it's correct, really. Okay, now. We need to revise. Okay. Uy, pait kayong on the spot do. On the spot solving the problem. Okay. Though it's a challenge, but it's so casky. Oh my gosh. Kaloka. Okay. Go back to business. Okay. Like that. So aluminum solid. Okay. Aluminum solid. Remember first trial 5 attempts. And we don't know for the second trial. Okay. Plus HCl. Okay. Gas is equals to aluminum chloride solid plus H2 gas. So you need to balance first the aluminum, right? Am I correct? Yes, the aluminum is really balanced here automatically. Hydrogen is not yet balanced. Okay, then you have to put 2 immediately. We are doing now the direct because we are showing you the systematized and detailed fashion of showing the balancing in my first trial. Okay, okay, let's agree. Okay, so we have to put 2 in the HCl to make it balanced. Okay, like that. What about the chlorine? The chlorine is not yet balanced also, so we need to put chlorine 3 in the side of HCl. Right? Correct or not? Now think. Okay? Chlorine. So chlorine is 3 here. Okay? Okay. 3 HCl. Like this. Okay. Now, aluminum, balance. 3 chlorine balance also. And the hydrogen is our problem now. Okay. Our hydrogen here, so we have 1 mole of hydrogen gas, the subscript is 2. So if we leave that as x, so that is 2x over 3. So x is equals to 3 halves, and we have to put 3 halves here in the hydrogen gas. Okay, 3 halves hydrogen gas. Now, if we leave the concept and principle that we don't have to simplify, that just as is because it's already balanced, even though having the fraction. Because in my first trial, guys, I really forced to avoid the fraction. Okay, if you try to avoid the fraction, it will reach you to different attempts or how many attempts in balancing the chemical equation. Now, I came to think at this point, how about just leave the fraction? Anyway, this is balanced already. Okay? This is another concept, okay? Or this is logical also, okay? But not in the real sense because there's no fraction of number of atoms in the chemical reaction in the actual. Okay? It's only purpose of solving man siya talaga. Okay? It's already balanced here. Why I say balance? Why I say balance, guys? Because 2 times 3 is 6, 6 divided by 2 is 3, 3 is hydrogen on the other side. So this is balance. First step pa lang siya na balance na siya. Because I don't want to cancel the improper fraction. In my first trial, I forced to cancel the fraction, in which very difficult to follow that one. Okay, because if you do that, the aluminum also will be multiplied by here. To avoid that complication, we need to leave as is lang the fraction. Anyway, the purpose is for computation. Okay? Like that. 3 halves H2. But in normal cases, guys, this will be avoided talaga ang fraction. But for the purpose of only getting the enthalpy change. This is balanced already perfect. This one. Okay? So, aluminum solid plus 3 moles of HCl, aluminum chloride solid plus 3 halves of H2 gas. Okay, we have a fraction. This is our first option. Let's leave this way. Second option, again, we need to cancel the fraction. Okay, gusto mo ko i-cancel ako ang fraction kay wa ko maanad ang chemical reaction. Okay? Gaya ko uno. Because I want really to justify. I want really to dig it out. That's why. Okay, so I need to multiply that with 2 so that the fraction will be cancelled. Okay. So it will become now 2 aluminum. Hunus, mabalance ko dahil siya in avoiding the fraction. This is my second trial, ha? So 2 aluminum solid plus 2 siya, so 6 moles of HCl gas. Oh my gosh! This is the effect of, solving on the spot. Okay, and then, okay, 2 aluminum chloride solid. And then, 3 halves times 2, guys. So, cancel. 3 moles of H2 gas. So, this is our option 2. Okay, in my second trial, this one, I leave first the 3 halves because this is balanced already. I don't have to avoid the fraction. Okay, and in my second analysis, I have to avoid the fraction. That's why I multiply by 2. So this is the result. Now I have to balance the number 2 if really balanced in avoiding the fraction. Okay, aluminum 2. Aluminum on the other side is 2. Kulbaan dyan ko char. Kapait. Actually, if you will just memorize immediately, no need to go further this kind of, presenting the discussion. Aluminum is equals to 2. I don't memorize kasi. Okay, and then, okay. Hydrogen, 6. Hydrogen on the other side, 6. Okay, aluminum is aluminum, 2 aluminum like this, 2 aluminum like this. Okay, the aluminum is 2, guys. Balance siya, aluminum. Hydrogen balance siya 6. How about the chlorine, guys? 6. Yes! Perfect! Balance siya. So we need to use this number 2 option. Perfect. Balance chemical reaction. Oh my God, it took me so very long to balance the chemical reaction. See?
The Bluetooth device is ready to pair.
See, guys, I do 2 trials before I get the correct perfect balance equation. So meaning to say, this implies that balancing the chemical reaction and chemical equation needs to be patient and to review your chemical equation from time to time if it is really logical and valid, okay, by adapting the algebraic expression in algebra, okay, this one. So I got correct already, perfect. And now we need to solve now the, it's balanced already, see? My point is I did not get immediately, that's the point, okay? At least we learn, right? Rather than memorizing and practicing this and then showing to you, then it's not challenging, right? Because it doesn't lead you to think. Okay, how can you sharpen your mind if you are dependent already what you see, okay, or you practice? It's not like that, okay? So, calculate the enthalpy formation of gaseous hydrochloric acid. Oh my gosh, how can I do this? Okay, calculate the enthalpy of formation of gaseous hydrochloric. Okay, hydrochloric acid meaning to say reactant. Oh my gosh, reactant shock. Okay, so the change of enthalpy in the formation of the hydrochloric acid gas. Okay, so let's check. Let's check comprehension. Wow. Meron ba yun? Okay. Wow. I balance the chemical reaction. Okay. So, change in enthalpy of the formation of the reaction, delta H F R X N, it's gonna be like that, right? Is equal to the summation of the enthalpy change of the formation of the product. Our product is aluminum chloride. So aluminum chloride, okay, in gaseous state, okay, times the number of moles. How many moles in our balance equation here that we balance this perfectly? So we have 2 moles of aluminum chloride. Charot. Okay, I just put that 2, okay, and then plus the summation of hydrogen gas enthalpy heat of formation, enthalpy formation, okay, reactant ha, so H2 gas times the number of moles in the balanced chemical reaction, which is 3, okay, multiplied by 3, ganon, okay, minus to the enthalpy change of the reactants formation, which is composed of aluminum and hydrochloric in a gaseous state. Okay, right. So, summation of the enthalpy of the aluminum solid, okay, plus times the number of moles of aluminum in the reaction, that is 2. Don't forget the number of moles, because the unit of enthalpy is in kilojoules per mole man siya originally. Okay, so times 2. Yup. Okay, plus the enthalpy change of the reactant gaseous HCl. Okay, and then times the number of moles, which is 6 moles of HCl in the chemical reaction. So times 6. Okay, do the math. Okay, do the math. Okay, substitute values because we have enthalpy formation given in the problem. So in here, okay, let's check. So the enthalpy formation for aluminum chloride is negative 7. Oh my gosh, spontaneous. Okay, enthalpy for aluminum chloride. Okay, so substitute here. Okay, aluminum chloride given negative 704 kilojoules per mole times, okay, this is 2 for the aluminum chloride. Yup. Okay, so 2 moles like this. Okay, aluminum chloride. Okay, that is negative 704 kilojoules moles times 2. Okay, and then plus the change of enthalpy formation of the hydrochloric gas. So here, hydrochloric gas, how much? Calculate the enthalpy. This is being asked. So let this as X. If it is being asked the technique in mathematics or in engineering calculation, you have to put that as x as your quantity or variable to find out. Okay, or let's just have enthalpy of HCl. It's just like that. But x is more simpler than to put enthalpy. I guess it takes time, but I'll just put this as let x as the enthalpy formation of the reactant of the gaseous hydrochloric acids. I will put X. Okay. So this means this is the delta H of HCl in a gaseous state. If I have to put that in perfect words, but I just put that as X in algebraic expression so that it will be easy. Okay. So X times 6. Because mathematics is always like that. Or engineering calculation. Let the value of x, okay, so minus the enthalpy change of the formation of the aluminum solid. Theory and concept, basic theory and concept. If it is a solid, a single element that is not a compound, whether gas, solid, or liquid, automatically at 25 degrees Celsius or 208 Kelvin at standard temperature and pressure, the enthalpy change of the formation of the particular element will be equal to 0. So I don't have to put na because 0 by theory and concept. Okay, now I go directly to the HCl. The enthalpy change formation of HCl, which is given by siya. Okay. The enthalpy change of reaction is negative kasi given ba siya or wala? So wala siya. So put that as X. Okay? Kung wala siya. So, ganun. So let's review. Okay? Okay. Samo kayo siya pagka-present. Okay? Ganun. Patient, right? Okay? Patient. So, if that is the case, the scientist, one of the qualities of scientist is patient. Okay, that's why in science you do a lot of experimentations just to prove your scientific research to be true, to be valid, to be reliable, and to be accepted to everybody. So this is gonna be science all about. You don't have to be ashamed if you repeat over and over again because that's really part of scientific method in your scientific research. So that you can come up with your own scientific discovery. So that's why that is one of the qualities of a scientist, is to be patient. Just like a driver on the road, you have to be patient because there's a lot of motorists in the road. Okay, you have to consider their part, not only yourself. It's just the same like that analogy also in solving any kinds of problem. You don't have to hurry because if you hurry, then you will be wrong somewhere along the way or you get accident somewhere along the way. Okay? That's very clear. Okay, let's change the concept and the idea that if the student cannot get exactly the correct answer right away, that they are not good. So let's change the concept. That's not true. Okay, we need to review, do it again. So that's gonna be the process of problem solving. That's why we have practice problem solving so that we can learn a lot. Okay, because mathematics is just only practice and make it perfect. Okay, especially to those people who are not good in mathematics, just like me. Okay, admittedly I'm not good in mathematics. Okay, so that's one. Okay, so review. So aluminum chloride change of enthalpy formation is negative 704 plus product. Oh, see, this H2, not HCl. Okay, H2. Okay, Okay. So ang H2 is 3 ra siya. So meaning to say X times 3. But H2 guys is 0 na ni siya. Because as I said earlier, solid, liquid, and gas exist in a free state is 0 man siya. So I don't have to put X times 6. Okay? See, I reviewed immediately because, what's happening? Ganon. Okay? So, the power of review matters a lot. Okay? So, 0 na siya. So, let's go to the reactant na siya. Okay? So, aluminum. Okay? Okay, makabuang yun yung chemical ko. Sorry. Okay, aluminum solid. So, aluminum is 0 siya. Kaya wala yun na siya enthalpy. Okay, basta usara ka element. Okay? So, 0 minus HCl pila siya. HCl, this gonna be the one we are asking for. That we let X. Advance na kaya akong huna-huna. Okay? HCl. Muna na siya times 6. See? Nagdali. Okay, because I have another appointment. Charot! Okay, ganon. So, negative 704 times 2. My calculator. I cannot do this by my brain. Okay, so I just do this without using the calculator. So, 8. This is 1,408. 1,408 without using the calculator. Okay. Kilojoules. Okay. Then, minus, negative siya, HCl. So that is 6x. And then our reaction given method siya, no? Okay. Ilan may gatag mo sa kuan? Sa reaction. Ilan gihatag niya? O, negative 856 siya. Okay. Nadara. O, naghatag magod niya, dara o. Okay. So, negative 6 kilojoules per mole siya. O niya, pila naman siya. Okay, negative 856 siya. Okay? Muna na siya. So, 6x plus minus 148 kilojoules times 856 kilojoules per mole. Okay? Like that. So, the reaction here to be understood to be 1, well, why? Concept na sa theory na po. Why? Balik ko na to atong chemical balance, chemical reaction. Okay, this one. Okay. This one. Oh my gosh. Nakakaluka. Dili man mo balance sa ikaduha. Okay, dali. Okay. So, ganon. So, solve for the value of x. Algebraic expression na lang din ni siya. So, 6x negative 140r. Linear siya. Linear algebraic expression is equals to 856. Because walang exponent, linear ang tawag niya, di ba? Linear algebraic expression in algebra, right? So, 6x equals to blah, 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 so and so. Okay. Without using the calculator, nagdali yun. Bisig nag-patient na. Charot! Okay. 856. Di madaoy, may calculator. Oy, nasod sa akong brain. I have to use the calculator talaga. Okay. Hello, John. Are you still there? Where's my calculator? Sarap. For calculator, please. What is it? Okay. So, this is negative 856 plus 1408 siya transposed. So, 856 transposed. 856 negative 856. Okay. Plus 1408. Okay, ganun siya. In fairness, chupa-chucho. Negative 856 plus 1408 is equals to divided by 6 is equals to. Okay, x is equals to 92. Okay, 92 kilojoules. Reaction. So, review ha. Because you review because why it is non-spontaneous. Review again. Non-spontaneous siya. Why? Let's check. Positive value of enthalpy is non-spontaneous man siya, but we know in the first place, the theoretical aspect, that this is this is spontaneous, but the answer is non-spontaneous. So something wrong with our calculation. We need to agree with the theory and concept. Again, we need to go back. Ganon siya ha. Yun ang gamit ng theory. Because your answer will not be, will not hold true to the concept magod siya. Then we need to review. It's not enough that we substitute like this. Maybe we are wrong. Okay? Okay. Again. Charot. Enthalpy change of aluminum chloride gas. Ano, sorry, it is solid. Solid siya ha. See? It doesn't matter because that's only a phase, but again, it's not good also to teach that phase is solid and then gas. It's not good, right? You have to correct, really. Okay? Like that. So, aluminum chloride, guys, pila. Review the problem. Charot. The enthalpy, negative 704. Okay, sige, negative. Oh, correct, perfect. So, the number of moles of aluminum chloride is 2. Okay. So, 704 times 2. Okay. Let's review because it's not logical talaga that we could achieve the non-spontaneous, that our given all are spontaneous. So how come? Okay? So something wrong with the concept. No, something wrong with the solution. The concept is really correct. Okay, so negative 1408 and then plus 3 moles of hydrogen gas. Hydrogen gas exists as a free state. Do zero na siyang enthalpy formation. Okay, zero. Okay. Minus reactant. 2 aluminum. Again, free state, 0. Okay. So, minus HCl times 6. Pila man atong HCl? Wala man siya pangita ang HCl. We find the enthalpy formation of HCl. So, that is X. So, in the reaction, we have 6 moles of HCl. So, 6 X. Okay, ganun siya. So, negative 1408 minus sign. Basta sa signs na nagdaog ani ron. So, negative 1408. Okay, negative. Minus 6X. Okay. And then we have a negative on the other side, which is, again, spontaneous. Negative 856 for the reaction. Okay. Now, do the math. Again, 6x is equals to negative 856. Okay, negative 56, mahimo siyang positive ang 1408. Okay. Ganon siya. So, 856, negative 856 plus 1408. 552. 552 divided by 6 is equals to 92. Wala, oy. Fairness is equals to 92 joules. So this is, for the second try, this is really non-spontaneous. And what make this non-spontaneous? Okay. What this make non-spontaneous? Let's review now. Okay. What makes this non-spontaneous? Okay. This is hydrochloric acid. And now we will review also the hydrochloric acid property. If it always have the positive enthalpy. Okay, something like that. This really positive, even though we keep on reviewing this positive. So it deviates the theory. Oh my gosh! Okay, again, we need to use the second law of thermodynamics. Ganun lang. Sure. Okay, go. So, delta G gives free energy. Okay, is equals to delta U minus T times delta S entropy, right? Delta G is equals to delta H minus T times the entropy. Okay. Now we have an enthalpy. Enthalpy is directly proportional to the Gibbs free energy, but inversely proportional to the entropy. Okay, if we have a positive, we have also positive delta G. Now, if we have a positive delta G, this is greater than or equal to 0, so we have a reaction that is favored to the reactants. Why it is being favored to the reactants? Let's check the value. Favored to the reactants. Okay, 92. And then the other one is aluminum chloride. Pila man aluminum chloride ay negative. It's being favored in the reactant. 92. Okay. It's being favored in the reactant because the delta G is greater than 0. So it's favored in the reactant. So that means if we talk about favored class in physical chemistry and thermodynamics, that is always positive. Okay? So it answers the theory. Wow. Really? It's gonna be like that, okay? I reviewed the first law of thermodynamics, I reviewed the second law of thermodynamics, I reviewed the relationships between delta H and delta G and the entropy, and I found out that if the Gibbs free energy is greater than zero, because we know that enthalpy is directly proportional to the Gibbs free energy, and we obtain a positive value of 92 kilojoules is positive, right? And then in theory and concept, if the value of the delta G is positive, that is favored man gud siya. Okay, you understand now? It is favored man siya, basta positive. You understand? So the point? So it is favored siya. So if it is favored, that is a positive value of HCl, and it's correct. Meaning to say that in here, we are referring only to the delta H of the HCl, which is non-spontaneous. But the overall reaction is spontaneous. Dara di ay. So muna siya ang correct concept. Again, we obtain a positive 92 kilojoules of delta H of the HCl in gaseous state. Why? Because it is being favored due to the fact that the Gibbs free energy is directly proportional to the enthalpy, which is favored at the positive value. That's the first theory. It meets. Second theory. Okay, since HCl is individual in the reactant, it doesn't reflect the reaction, right? So our reaction value is negative 856 kilojoules. That means spontaneous. The reaction is spontaneous, the overall, but the HCl enthalpy in its individual aspect is non-spontaneous. Muna na siya. Gi-breakdown na nato. Okay? So the HCl will exist in non-spontaneous by himself alone, but if HCl will do the addition of other chemicals in the chemical reaction, the whole overall reaction is spontaneous because we obtain a negative 856 kilojoules for enthalpy change of the reaction man siya. So, directly proportional sa Gibbs free energy, so negative siya, so that is spontaneous ang reaction. But individual for HCl is non-spontaneous because we obtain an enthalpy of positive. Very clear now. Okay? So, our theory is correct, and at the same time, our solution is correct. Bingo. Okay? Any questions so far? It took me 1 hour and 20 minutes to solve this one problem. Here. That means you need to think talaga siya, and you have to be patient. Something, and you have to repeat. If your steps are something illogical, invalid already, then you have to connect the theory and the concept. Not enough to obtain an answer. Like that. Because sometimes also, you have the correct formula and then you obtain an answer, then you will really believe that it's already an answer. No, it's not. Because the choices also sometimes in the examination, the questionnaire also, they put that also to trick you out. But the real answer is not yet that one. Okay, you get the point now? Okay, so that's the confusion and the trick, TRICK of the question. The author of the questionnaires, something like that. They put the exact value, okay, but that is not really the real answer. If you connect the theory and and the problem solving, okay, basing on this like this. So many steps, right? First, second, third, fourth, fifth, like that, and first trial, second trial, like that. Okay, my gosh. Thank you so much, guys. If you enjoyed it, really, me, I enjoyed too much. Okay, because I'll never stop if I cannot get the answer. Really. Okay, that's my attitude talaga when I was in college. I will never stop if I cannot solve the problem. Okay, like that. And I have to research different books just to, just to satisfy what's on my mind. Something like that. Okay. Oh my gosh. Okay, time check. Oh, meron pa akong time. Thank you so much, Lord, for giving me a knowledge to justify this problem number 2. Okay, this one. If you think if you didn't, you can share this to anybody else to add academic information pertaining to the enthalpy change of the reaction topic. And also, you can subscribe and like the channel if you want. Also, and you can click the notification bell of some news episode and sing our eternal voice. Bye bye. God bless everybody. See you later. Ganon. Charot.